Welcome to our channel. Today we will learn about deviation, dispersion and spectrum from chapter Spectrum for 10th ICSE. So let us start. Okay, so first we will discuss about deviation produced by a triangular prism. Already in previous videos we will discuss about the prism कि what is a prism. Prism में दो refracting surfaces होते हैं and through the refracting surfaces refraction takes place. About that we have to discuss further. So deviation produced by the triangular prism. Deviation produced by a triangular prism. This is the prism ABC. It is a triangular prism. Triangular prism ABC, it is there. This is the incident light. This is incident ray. It incident at the refracting surface AB. AB is the refracting surface. AC is also refracting surface. So this prism having two refracting surfaces AB and AC and with the angle of prism as A. So in this case we have to learn about the deviation produced by a triangular prism, how the incident ray deviates in this case. So as in it incident, the ray incident at the refracting surface and this is the normal. This is the normal. So its actual path should be like this one, but it as a what is here, air it is, and it is the glass. As the light is traveling from rarer, that is air medium, air to glass, air medium to glass medium, or rarer to denser, then it bend towards the normal. Its actual path should be this one, but it bend towards this. So this is actual path. Okay. And at the second surface again refraction takes place. This is the normal, I can say. This is the normal which is not shown in the diagram. This is normal. Actual path should be this one, but it goes away from normal because now it is moving from denser to rarer medium. Okay, so we are observing two deviations over here. In fact, three deviations we can see. So what are the deviations as we are observing? This ray as incident on this surface, its actual path should be like this, but it bent towards this one, right? So this angle is angle of deviation. So delta 1 is the angle of deviation. Now next part, as light is entering from glass to air medium here, its actual path should be like this. ये बीम का एक्चुअल पाथ ऐसा होना चाहिए, but it refracted, it is emergent ray, it comes over here. So this is the angle of deviation, that much this ray has deviated. It is delta 2. It is again angle of deviation, and one more angle is here. As we can see, if we will extend this ray as well as this ray to this direction, so this angle is again angle of deviation. So these all are the angle of deviations. So deviation produced by the triangular prism. There are some factors at which deviation will depend. What are those factors? About that we have to study, and for that in previous topic refraction through surfaces we were in prism part. Already we have studied, so we will continue with the formula. Lot of things we can get from there. So we were studying two formulas. One formula was A plus delta is equals to I plus E. What are the terms? Terms must be clear. A is the angle of prism and delta is the angle of deviation, I is the angle of incidence and E is the angle of emergence. So this is the relation between A, delta, I and E. So if we will say कि जो angle of deviation delta है, it will depend on what factors. So first factor is the angle of prism, this angle. Second factor will be angle of incidence, that is this. Third factor may be angle of emergence, but we can't say it as a factor. And we can say one more thing, it will depend on the refractive index of the material of the prism. Refractive index of this, if we will say ki it is made up by glass, then we have to consider about the refractive index of the glass. So another formula is there by which we can decide on what factors this angle of deviation will depend. So one more formula already we know that I can write. We have studied, since refractive index of the prism is sine of A plus delta m, m for minimum deviation, by 2 upon sine of A by 2. This is the prism formula we call, prism formula, and by these two formulas we can say कि what are the factors at which angle of deviation will depend. So angle of deviation will depend on the angle of the prism, or sometimes refracting angle of the prism, that is this angle, and refractive index of the material used for the prism, this. So prism ka refractive index we can use, means with what material it has been formed. Like usually prism is made up by glass or sometimes flint glass also, normal glass or flint glass. So that depends. Okay, and one more observation already I have written here. What will be angle of minimum deviation or this deviation delta? So what is our observation? If this angle is delta 2, so this angle also will be delta 2. This angle will be delta 2. And we can say this delta is the exterior angle for this triangle. For this triangle. This is the exterior angle. And we know, according to exterior angle property of a triangle, the sum of the internal angles, that is this angle alpha delta 1 and this angle is delta 2. So delta 1 plus delta 2 is equals to delta, that we have written over here. Delta is equals to delta 1 plus delta 2. Okay, now we will discuss about some factors. Already two factors I have mentioned. So further part we have to discuss. Okay, so here we have the total angle of deviation delta, thus depend upon the following three factors. What are those factors? Already I have mentioned. From this relation I have mentioned that delta will depend on the first factor, that is angle A, angle of incident, angle of prism or refracting angle of the prism, and angle of incidence IA, and even emergence, but emergence is not a factor. Remaining all the angles will depend on the angle of emergence. Okay, and third is the, by this one I have mentioned. Okay, just I will read one by one. So the angle of incidence, ये जो तीन factors हैं, उसमें पहला factor है कि the angle of deviation delta will depend on the angle I, delta will depend on the angle I, delta will depend on the angle A, which is the angle of prism A, and one more factor, the refractive index of the material of the prism, that is mu. So deviation, angle of deviation will depend on the three factors we have decided by the formula also. First is the angle of incidence, second is the angle of prism, and third is the refractive index of the material of the prism. Okay. Next is dependence of deviation on the color of light. Dependence of deviation on the color or wavelength of light. One thing I will tell you before starting this one. We know that red light is used as the danger signal. What is the reason behind that? Because red light will be visible to us from very long distance. Reason is that why it will be visible from very long distance? Because इसका डेविएशन, इसका मतलब रेड कलर का डेविएशन लीस्ट होता है. रेड कलर का डेविएशन सबसे कम होता है, इसलिए वो अपने पाथ से डेविएट नहीं होता है. दैट इज द रीजन इट इज विजिबल टू अस फ्रॉम वेरी लॉन्ग डिस्टेंस. और ये डेविएट कम क्यों होता है? बिकॉज इट हैव, रेड कलर हैव लॉन्गेस्ट वेवलेंथ. So it is visible to us. अच्छा, लॉन्गेस्ट वेवलेंथ है इसलिए डेविएशन कम हुआ, और डेविएशन कम हुआ तो विजिबिलिटी विल बी मोर. इट कैन बी विजिबल, इट विल बी विजिबल फ्रॉम वेरी लॉन्ग डिस्टेंस. ओके, सो दिस इज द जनरल इंफॉर्मेशन which will help us to study further. We will see. So dependence of deviation on the color or wavelength of light. Refractive index of the glass, the material of prism, increases with the decrease in wavelength. So what relation we can say? Refractive index, that is mu, is increasing with the decrease in wavelength. Means one is increasing, another is decreasing. So what will be relation between in these two? I can say refractive index of the material of the prism will be inversely proportional to the wavelength. So what is the relation between these two? They are inversely proportional to each other. So what is the conclusion of this one that already I have written here? That is, the refractive index of the glass is inversely proportional to its wavelength. As wavelength increases, refractive index will decrease, or we can say as refractive index increases, wavelength will decrease. And why it happens? Because we know the speed of light is different in different medium. हमने बेसिक जो प्रीवियस वीडियोस में आप लोग देख सकते हैं, वहां हमने ऑलरेडी प्रीवियस टॉपिक्स में पढ़ा हुआ है कि जो स्पीड ऑफ लाइट है वो हर एक अलग अलग मीडियम में अलग अलग होता है. सो स्पीड ऑफ लाइट चेंजेस विद डिफरेंट मीडियम्स, बिकॉज हर एक मीडियम का रिफ्रैक्टिव इंडेक्स अलग अलग होता है. तो जो डेंसर मीडियम होगा उसमें स्पीड ऑफ लाइट विल बी लेस, तो उसका रिफ्रैक्टिव इंडेक्स ज्यादा है, और जिसका रिफ्रैक्टिव इंडेक्स ज्यादा है उसमें वेवलेंथ कम होगा, या जिसका वेवलेंथ कम होगा उसका रिफ्रैक्टिव इंडेक्स ज्यादा होगा, बिकॉज दे आर इनवर्सली प्रोपोर्शनल टू ईच अदर. So this is the final conclusion about this one, that the refractive index of glass increases with the decrease in wavelength of light. Okay. Therefore, the deviation caused by the prism also increases with decrease in wavelength. Deviation, अब दोनों में एक रिलेशन है. अगर वेवलेंथ बढ़ा तो रिफ्रैक्टिव इंडेक्स कम होगा, या रिफ्रैक्टिव इंडेक्स ऑफ द ग्लास विल इंक्रीज विद द डिक्रीज इन वेवलेंथ, और डेविएशन जो है वो भी इनवर्सली प्रोपोर्शनल है टू द वेवलेंथ. सो जिसका रिफ्रैक्टिव इंडेक्स ज्यादा होगा उसमें डेविएशन कम होगा, जिसका रिफ्रैक्टिव इंडेक्स कम होगा उसमें डेविएशन ज्यादा होगा. तो आई कैन कंक्लूड दिस वन as here कि angle of deviation delta is inversely proportional to wavelength. As wavelength increases, this wavelength is in denominator. और हमें पता है कि अगर किसी fraction का denominator is going to increase, so its value will be decrease. So it is inversely proportional. This lambda increases, wavelength increases, so angle of deviation decreases. Okay. And again, I will correlate with that. Initially, I have mentioned red color का light का deviation सबसे कम होता है because उसका wavelength is maximum. Red color का light का wavelength is maximum. So उसका angle of deviation will be minimum. जिसका wavelength जितना ज्यादा उसका angle of deviation उतना कम. So this is the relation, and very important relation, logical relation is that one, so you can remember it. Again, we can conclude the first part. What we can say, the refractive index of the glass or any material of the prism increases with decrease in wavelength, and angle of deviation increases with decrease in wavelength or decreases with increase in wavelength. मतलब they are inversely proportional. और inversely proportional है तो one will increase, another will decrease. Inversely proportional का meaning ही होता है कि if one increases, another decreases, then they are inversely proportional. And directly proportional में one increases, another also increases. X increases, Y also increases, then they are directly proportional. X increases, then Y decreases, then that is inversely proportional to each other. Fine. So till here everything is clear. Now further, in visible light, violet color having wavelength 4000 angstrom, we have to remember it, and 1 angstrom is 10 raised to minus 10 meter. That relation also we have to remember. So in visible light, violet color is deviated the most and red color is deviated least. As we can say, deviation we are talking, again I will write that part. Delta, angle of deviation, is inversely proportional to wavelength. So what we can conclude from here, as wavelength increases, so angle of deviation decreases because they are inversely proportional to each other. And what we can observe over here, for violet color का wavelength is 4000 angstrom and red color having wavelength as 8000 angstrom. 8000 is greater than 4000, so we can say wavelength of red color is greater than that of the violet color. That conclusion also we can write over here. Wavelength, that is a lambda r for red color, is greater than r, I will write capital, as compared to delta v. Sorry, not delta, lambda we can write. Lambda, that is wavelength of red color is greater than wavelength of violet color, because it is given to us. It is lambda v for violet and it is lambda r for red. Okay, and we are observing lambda r is greater than lambda v. Lambda is the wavelength, r is the red color, v is the violet, and again lambda is the wavelength. So, and what we have observed over here, delta is inversely proportional to wavelength, and we are talking if wavelength of red color is greater than wavelength of violet light. So we are talking about the wavelength, so lambda will be just reverse of that. We can say therefore we can say delta r will be less than delta v. We are talking about this part. If deviation of if wavelength of red color is maximum, then deviation will be minimum. And for violet, wavelength is minimum, so deviation will be maximum. Okay, so these conclusions are very important for us. Okay, next part is the colors in white light with their wavelength, colors in white light with their wavelength and frequency range. So we know wavelength is the characteristic of color is irrespective of its origin. Wavelength means we know one thing, already we know about one experiment, Newtonian plate. न्यूटन ने एक एक्सपेरिमेंट किया था, जस्ट आई विल टेल यू अबाउट दैट. न्यूटन ने क्या किया था, एक डिस्क बनाया, that is also called as Newtonian disk, and he classified, what we can say, divide that disk into seven equal parts. 1, 2, 3, 4, 5, 6, 7 equal parts. I have not done it equal, and he colored each and every term with red. I can say V, I, B, G, Y, O, R. These are the colors of a spectrum. And he rotated this disc. Then he observed that it looked like white. So he concluded that 7 colors are nothing but the part of white light. And we know if any white light is going to be passed through the prism, it is split into 7 constituent colors, and those all the colors are Vibgyor. About that we have to discuss. I will tell. So colors in white light with their wavelength and frequency range. Okay. So wavelength is characteristic of color irrespective of its origin. Fine. Means different colors of light are responsible due to different wavelengths. As I have mentioned, कि red and violet light में wavelength red का ज़्यादा है, तो definitely they have the different wavelength. And as the light will have their different wavelength, so they will have their different colors. इसका मतलब क्या हुआ कि हर एक लाइट का अलग अलग वेवलेंथ है, और अलग अलग वेवलेंथ की वजह से उनका अलग अलग कलर होता है. We can say. And I already have mentioned कि white light consists with the 7 constituent colors, and those colors are the part of the spectrum Vibgyor. Violet, indigo, blue, green, yellow, orange and red. We will see further. Okay. So dispersion of white light through a prism and formation of a spectrum. अब ये दो terms है. एक dispersion क्या होता है और spectrum क्या होता है? We have to discuss about it. Dispersion and spectrum. तो सबसे पहली चीज एक हम लोग देखते हैं रेनबो. जब रेनबो बनता है तो इन रेनबो वी कैन ऑब्जर्व दैट देयर आर द 7 constituent colors. 7 colors are there and they are Vibgyor. अगर प्राइमरी रेनबो है सो उसका कलर विल स्टार्ट विद द नीचे से वॉयलेट, इंडिगो, ब्लू, ग्रीन, रेड, ऑरेंज. एंड अगर वो सेकेंडरी रेनबो है तो उसका कलर उल्टा होगा, ऊपर से स्टार्ट होगा. ऊपर पहले वॉयलेट, इंडिगो, ब्लू, ग्रीन, ऑरेंज, रेड. दैट इज द डिफरेंस बिटवीन प्राइमरी एंड सेकेंडरी रेनबो. आई विल नॉट टेल यू इन डिटेल बिकॉज दिस इज नॉट द पार्ट ऑफ दिस, बट एनीवे. नाउ वन मोर ऑब्जर्वेशन यू पीपल मस्ट हैव एक्सपीरियंस्ड कि if any white light is passing through the prism, then there is the spectrum, or we can say pattern of 7 colors, and that pattern of 7 colors is called spectrum. So what is the spectrum? That is the pattern of 7 colors when white light passes through the prism. Okay, that is the spectrum. And what is the dispersion? Dispersion is the phenomenon of splitting of white light into its constituent colors while it is passing through the prism. या हम लोग वो प्लास्टिक वाला स्केल आता है छोटा वाला, वो स्केल कभी कभी आंख के पास रख के देखते हैं तो भी जो हमें बाहर की लाइट है वो वही 7 कलर्स में भी दिखता है हमें. तो वहां पे भी क्या हो रहा है, दैट एक्ट एज द स्मॉल प्रिज्म. सो एज लाइट पासेस थ्रू दैट व्हाइट लाइट फ्रॉम आवर आईज, दैट इज स्प्लिट इनटू 7 कंस्टिट्यूएंट कलर्स, and that forms a spectrum. Okay, so again I will mention what is dispersion. Dispersion is the phenomenon of splitting, or the process of splitting of white light into its constituent colors when it passes through a prism. That is the dispersion. That is the dispersion. Okay, so as we can see in this part, dispersion definition we will see later on. तो यहां पे हम लोग देख रहे हैं कि ये प्रिज्म है. This is the prism ABC, and through the prism we are passing the white light as it incident. यहां पे white light जो है वो 7 constituent parts में split हो गया. Observation देखना हमें, ये फर्स्ट रिफ्रैक्टिंग सरफेस है, ये सेकेंड रिफ्रैक्टिंग सरफेस है. AB is the first refracting surface. I can write AB is the first refracting surface, and AC is second refracting surface, because refraction takes place from these two surfaces. So what we can conclude, what is our observation? White light is here, it is split into 7 constituent colors. The process of splitting of white light into its constituent colors is called dispersion. तो dispersion कहां पे हुआ? At the first surface. Diagram बनाते समय we have to टेक केयर अबाउट दिस पार्ट कि डिस्पर्सन हमेशा कहां पे होना चाहिए? फर्स्ट सरफेस, फर्स्ट रिफ्रैक्टिंग सरफेस. ओके, एंड एज इट पासेस थ्रू द सेकेंड सरफेस, तो क्या हुआ? एज वी कैन सी, ये फर्स्ट लाइट है तो इसका एक्चुअल पाथ ऐसा होना चाहिए, बट ये डेविएट हो गया. आई एम टॉकिंग अबाउट रेड. तो सेकेंड सरफेस से क्या होता है? डेविएशन होता है. थ्रू द फर्स्ट सरफेस क्या होता है? डिस्पर्सन टेक्स प्लेस एट द फर्स्ट सरफेस, एंड एट सेकेंड सरफेस क्या होता है? डेविएशन होता है. तो दैट आल्सो वी कैन राइट. इट इज अ काइंड ऑफ कंक्लूजन. एट फर्स्ट सरफेस, एट फर्स्ट refracting surface, what happens? Dispersion takes place. Dispersion takes place, and at second refracting surface, at second refracting surface, deviation takes place. Deviation takes place. Okay, so very important points are these. Okay, so we can see here, this is white light as it passes through the prism ABC. It first is split into 7 constituent colors, मतलब फर्स्ट सरफेस पे डिस्पर्सन हुआ, सेकेंड सरफेस से क्या हो रहा है? डेविएशन हो रहा है. ये मैंने दिखाया कि इसका एक्चुअल पाथ ऐसा होना चाहिए, बट इट डेविएट्स. तो ये एंगल ऑफ डेविएशन फॉर रेड कलर हो गया, बिकॉज रेड कलर हैज बीन डेविएटेड दैट मच. ओके, एंड दीज कलर बैंड्स, 7 कलर का बैंड जो है दैट इज कॉल्ड द स्पेक्ट्रम. तो स्पेक्ट्रम में क्या आता है? विबग्योर फ्रॉम डाउन साइड आई विल से. Violet, V for violet, indigo, blue, green, yellow, orange and red. That I have written over here. Vibgyor. Violet, indigo, blue, green, yellow, orange, red. Violet, indigo, blue, green, yellow, orange and red. This is the dispersion by a prism. So in this part you have to remember this thing. At first refracting surface what takes place? Dispersion takes place. And at second surface what happens? At second refracting surface deviation takes place. Okay. Then Newton का मैंने example already दिया था. So that is here. What we have? Newton concluded that white light consists of 7 prominent colors. 7 prominent colors, and those all the colors are Vibgyor, violet, indigo, blue, green, orange and red. Now okay, red color is monochromatic light. Mono means same, chromatic, wavelength. And here we have polychromatic. So we can say white light consists with the 7 constituent colors, so it is the polychromatic. Monochromatic means single color or single wavelength. Polychromatic means white light, which consists with the 7 constituent colors. So example I will write for the polychromatic. Example will be white light is the polychromatic. And what is the monochromatic one? अगर मैं बात करूं monochromatic light. So monochromatic means monochromatic light, that is a light having single color or wavelength, because color is due to different colors of light are due to different wavelengths. Already I have mentioned in beginning. Okay, so next part is the dispersion. Already I have mentioned this phenomena is the phenomenon of dispersion. In this one, white light is split into 7 constituent colors. So that is the dispersion. So what is the dispersion? Definition is here. The phenomenon of splitting of white light by a prism into its constituent colors is known as dispersion. And what are the constituent colors? That is Vibgyor, violet, indigo, blue, green, orange and red. Next is spectrum. I have mentioned already the color bands after dispersion what we obtain, that is the spectrum. So on passing white light through a prism, the band of colors seen on the screen is called the spectrum, like Vibgyor. So we can write this is the spectrum of white light, Vib, G-Y-O-R. So this is the spectrum. Okay. Next, cause of dispersion of white light and formation of spectrum. So why dispersion takes place? As we can discuss again here, कि why dispersion takes place? Dispersion takes place due to different, we know कि when a beam of light passes from one medium to another medium, it changes its path. And deviation takes place. So white light consists with the 7 constituent colors, so all colors will deviate with the certain angle, and due to that it will split into 7 constituent colors, and that is the dispersion. Okay, so Cause of dispersion, I have mentioned everything over here. The cause of dispersion of white light is the change in speed of light. Change in speed of light with wavelength. When white light enters the first surface of the prism, first refracting surface, light of different colors due to their different speeds in glass gets deviated through the different angle towards the base of the prism. Already I have mentioned. Some note points are there. First is the dispersion of white light occurs only at the first surface of the prism. Already I have written there. At first surface dispersion takes place and second surface पे क्या होता है? Deviation takes place. Deviation of light rays occurs at both the surfaces of prism. The prism does not produce colors, but it only splits the various colors present in the light incident on it. Because I can say that when white light enters through the prism, so white light consists with the 7 constituent colors, so that will split only, right? So during dispersion, white light split into 7 constituent colors. Okay, so we complete A part, that is the deviation, dispersion and spectrum of chapter 6, spectrum for 10th ICSE. Please like, share and subscribe my channel. Thanks for watching this video.